Welcome to this explainer. Okay, let's dive into this. Today we're taking a look at one of the most fascinating and honestly kind of intimidating concepts in the entire cybersecurity world. We're talking about network pivoting. Now I know it sounds incredibly complex, but at its core, it's exactly like a classic high-stakes movie heist. We're just swapping out the bank vault for a digital one. We're going to break this whole thing down step by step, using simple words, completely demystifying how attackers actually move through a network, and, absolutely crucial here, how defenders can stop them dead in their tracks.
Here is our quick roadmap for today. We'll start with the island-hopping threat, then we'll break down the exact steps of a pivot, expose the secret tunnels hackers use, walk through a real-world HR database heist, and finally, wrap up by building some unbreakable defenses. Don't worry, we're taking this intimidating topic and making it super easy to follow.
All right, Section 1, the island-hopping threat, establishing the beachhead. To really wrap our heads around this, I want you to picture a standard corporate network as a massive, highly secure building.
So pivoting, which you'll also hear called island hopping, is basically when an attacker uses one compromised system to attack other systems on the exact same network. Imagine the company's public web server is like the welcoming, public-facing lobby of that secure building we just talked about. Hackers secure that initial spot as their beachhead. It's their safe base camp. And from there, they use it to launch attacks much deeper into the building, heading straight toward those hidden underground vaults that they could never ever reach directly from the outside internet.
Let's contrast what the hacker sees from the outside versus what they actually want to get their hands on. Your exposed assets, things like web servers or public-facing employee laptops, that's your lobby. Isolated assets, database servers, Active Directory domain controllers, financial records, those are the underground vaults. They are intentionally disconnected from the internet, locked away behind incredibly thick firewalls. And because the attackers simply cannot physically reach those isolated vaults from the outside, they're forced to pivot. They literally have to break into the exposed asset first and use it as a proxy to tunnel deeper.
Moving on to Section 2, steps of a pivot, moving deep into the network. Now, what's really interesting about this slide is that hacking isn't just someone furiously mashing random keys on a keyboard like you see in the movies. No, it's a highly structured process. They follow a very specific playbook.
Let's walk through the exact steps in simple words. Step 1. Compromise the foothold. The attacker exploits a known public vulnerability to install a payload, like a meter-preter shell. Think of this as a high-tech digital crowbar just holding the front door open. Step 2. Network reconnaissance. Once they're inside the lobby, they look around. They run ping sweeps to map out internal networks, say the 10.00.x range, just to see what else is nearby. Step 3. Set up the tunnel. They literally build a digital pipe routing straight through that compromised machine. And finally, Step 4. Lateral movement. Using that shiny new tunnel, they launch deeper exploits against the internal machines they just mapped out, sneaking sideways through the building until they hit the jackpot.
So, the crucial point is understanding the terrifying blind spot in traditional cybersecurity. You see, traffic originating from a trusted internal machine is almost always allowed by internal firewalls. Think about it. If a hacker attacks the vault directly from the outside, bam, the firewall stops them cold. But if they take over the receptionist's computer right there in the lobby and request access, the firewall just waves them right on through. The system trusts the computer, completely oblivious to the fact that a hacker is secretly pulling the strings from afar.
All right, Section 3, the hacker's secret tunnels, routing the traffic. Let's peel back the curtain and look at the actual technical mechanisms hackers use to dig these secret underground paths.
Attackers generally rely on three main techniques here. First up is SSH tunneling, also known as port forwarding. Basically, if they compromise a Linux server, they hijack the secure SSH protocol to build a reinforced, encrypted digital pipe for their traffic. Second is SOX proxying. Using clever tools like Chisel or Metasploit's autoroute, they completely transform the compromised machine into a malicious traffic cop, covertly routing their attacks much deeper inside. And third, port redirection. Here, they weaponize built-in computer utilities, stuff like Windows NetShell or Linux IP tables, to force the machine to blindly forward their traffic straight to an internal target.
Okay, Section 4, the HR database heist, an example scenario. Let's take all these abstract concepts and watch a real-world digital heist actually unfold step by step. The attack starts right here, at IP address 10.0.0.20. This is the company's public-facing web server. It's our exposed lobby. The hacker does some digging and discovers a remote code execution vulnerability. This is a critical flaw that lets them run malicious commands from miles and miles away. giving them total control over this entire server.
Now, once they are inside, the hacker does the reconnaissance and discovers something amazing for them. The web server is dual-homed. What does that mean? Well, it's literally like a room with two doors. One door faces the public internet, and the other opens directly into the highly secure internal network. Realizing they've struck gold, the attacker drops a tool called Chisel to build a reverse SOX proxy. This creates a secret, encrypted tunnel connecting the deep internal network straight back to the hacker's own laptop, and that hacker is probably just sipping a latte at a local coffee shop somewhere.
Which leads us to the ultimate target, IP address 192.168.2.50. This is the secure HR database vault. It is packed to the brim with sensitive employee records and buried in a completely separate, heavily guarded network segment. To the outside internet, this IP address is a total ghost. It is completely invisible and, theoretically, completely unreachable.
But hey, remember that secret tunnel we just built? Because of it, the hacker can now easily interact with that highly secure HR database. And this brilliantly illustrates the truly terrifying power of a successful pivot. The hacker is physically sitting at a coffee shop, but digitally, their laptop is routing all its tools and attacks straight through the compromised web server. To the HR database, it looks exactly as if the hacker's laptop was physically plugged into the wall, sitting right there inside the corporate data center. The entire perimeter security has been completely bypassed. Crazy, right?
So, Section 5, building unbreakable defenses, stopping the pivot. Let's move to and see how this builds our understanding of defense-in-depth strategies, because we definitely need to stop this from happening.
To truly protect your network, you need 3 primary defense layers. First, network segmentation, using strict VLANs. That's virtual local area networks. You're essentially putting up giant digital concrete walls, so a public web server can never, ever directly speak to an internal database. Second, micro-segmentation and zero trust. Listen, just because 2 employee laptops are on the same physical floor in an office doesn't mean they should be allowed to share network traffic. Devices must explicitly prove they're authorized to communicate. And third, you absolutely must monitor lateral traffic.
Let's break that last point down a bit more. Historically, security focused almost entirely on north-south traffic. That's data moving vertically out to the internet or south down into the network. It's essentially just checking IDs at the front door. But as we've seen, after a successful pivot, hackers move east-west. They sneak sideways from one internal machine to another. And guess what? Traditional firewalls completely ignore this. Security teams must actively watch the hallways. If a public web server suddenly starts scanning random internal ports, or the receptionist's laptop tries to use SSH to log into the HR database, alarms should literally be ringing immediately.
Whether you're learning ethical hacking in a home lab or you're designing an enterprise network to protect highly valuable assets, understanding the mechanics of a digital beachhead is absolutely vital. So I'm going to leave you with this final, provocative question to reflect on your own security posture. Are you actively practicing network pivoting to really understand the threat? Or are you just crossing your fingers and hoping your perimeter defenses hold? Thank you so much for joining me on this explainer. I really hope you're walking away with a much clearer understanding of how this digital heist works.